Today's lesson is on graphing integers on a number line, comparing numbers including integers, and finding the absolute value of integers. First, we'll look at our vocabulary. Positive numbers are greater than 0. They can be written with or without a positive sign. 1, 5, 20, and 10,000 are all positive numbers. They can have the positive sign or the plus sign in front of them, but they do not have to include that sign. Negative numbers are less than 0. They are written with a negative sign. -1, -5, -20, and -10,000. Those numbers have to have that negative sign in front of them in order for them to be negative numbers. Two numbers that are the same distance from 0 on a number line, but on opposite sides of 0, are called opposites. Now we're going to look at our key idea for integers. Integers are the set of whole numbers and their opposites. When you look at a number line, 0 is neither negative nor positive. 0 is its own opposite. On a number line, as you go to the left, your numbers are getting smaller. And as you go to the right, your numbers are getting larger. Now we're going to look at our first example. We are writing positive and negative numbers. Write a positive or negative integer that represents the situation. A contestant gains 250 points on a game show. Gains indicates a number greater than 0, so use a positive integer. So we can write plus 250 or just 250. For B, gasoline freezes at 40 degrees below 0. Below 0 indicates a number less than 0, so use a negative integer. So we can say -40. Now we're looking at graphing integers. Graph each integer and its opposite. So for A, we're going to graph 3. So on our number line, we'll put a dot at 3. 3 is 3 numbers away from 0. So we start at 0, we go over 1, 2, 3. So its opposite would be 3 away from 0 in the other direction. So we'll go to the left. 1, 2, 3, which would be -3. So the opposite of 3 is -3. For B, we're going to graph -2. So on our number line, we will put a dot at -2. And -2 is 2 numbers to the left of 0. So its opposite would then be 2 numbers to the right of 0. So 1, 2, and that would be the opposite. So 2 would be the opposite of -2. Now we are comparing integers. We're going to compare 2 and -6. In order to compare these, we can graph them. So first we'll graph 2 on our number line. We'll put a dot at 2, and then we can put a dot at -6. Remember, as your numbers are going to the left, they're getting smaller, and as you go to the right, your number is getting larger. 2 is to the right of -6, so 2 is greater than -6. For B, we're going to compare -5 and -3. So first we can graph both of those. We'll graph -5, and then we can graph -3. As our numbers go to the left, they get smaller, and as we go to the right, they get larger. -5 is to the left of -3, so -5 is less than -3. For our next example, we are comparing decimals. We're going to compare -3 and 8/100ths and -3 and 8/10ths. So first we can graph both of these numbers. -3 and 8/100ths would be between -3 and -3 and 1/10. And then -3 and 8/10ths would be graphed here at -3 and 8/10ths. Remember, as your numbers go to the left, they get smaller, and as we go to the right, they get larger. -3 and 8/100ths is to the right of -3 and 8/10ths. So -3 and 8/100ths is greater than -3 and 8/10ths. For our next example, we are comparing fractions and mixed numbers. For A, we want to compare -1/2 and -3/4. So first we're going to graph both of these fractions. We can graph -1/2 on our number line, and we can graph -3/4. As our numbers are going to the left, they get smaller. As our numbers go to the right, they get larger. Negative 1/2 is to the right of negative 3/4. So negative 1/2 is greater than negative 3/4. For B, we're going to compare negative 4 and 5/6 and negative 4 and 1/6. So first we can graph both of our mixed numbers. Negative 4 and 5/6 would be right here on our graph, and then negative 4 and 1/6 would be graphed right here. Remember, as our numbers go to the left, they get smaller, and as we go to the right, they get larger. Negative 4 and 5/6 is to the left of negative 4 and 1/6, so negative 4 and 5/6 is less than negative 4 and 1/6. Now we have another key idea. This one's for absolute value. The absolute value of a number is the distance between the number and 0 on a number line. The absolute value of a number A is written as absolute value of A. The absolute value of negative 2 would be 2, because you can see that it is 2 units away from 0. Also, we can see that the absolute value of 2 is equal to 2, because it is also 2 units away from 0. Now we're looking at finding absolute value. Find the absolute value of 3. So first we can graph 3 on a number line, and then we can find out how far 3 is away from 0. 3 is 1, 2, 3 away from 0. Therefore, the absolute value of 3 is 3. For B, we're going to find the absolute value of negative 2 and 1/2. So we will first graph negative 2 and 1/2 on the number line, and then we're going to find the distance that negative 2 and 1/2 is away from 0. So the distance away from 0 would be 1, 2, and 1/2. So the absolute value of negative 2 and 1/2 is 2 and 1/2. You will see that the absolute value is always positive because it's the distance from 0. Now we're going to be comparing values. We want to compare 2 and the absolute value of negative 5. So first we need to graph both of these. First we'll graph 2 on the number line, and 2 would be right here on our number line. Then we need to graph the absolute value of negative 5. The absolute value of negative 5 would be 5, because negative 5 is 5 away from 0 on a number line. So the absolute value of negative 5 is positive 5. So we've graphed both 2 and the absolute value of negative 5, and then we can compare those. 2 is less than the absolute value of negative 5. Remember, as your numbers go to the left on a number line, they're smaller, and as you go to the right, they get larger. Don't forget to fill out your notes, and remember, you can watch the video again if needed.